Hello everyone, welcome back. Myself Rahul. So today we are going to solve a very interesting problem called edit distance. So let's go through the problem. Given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. It's a very interesting problem and very popular problem. So you have the following three operations permitted on a word: insert a character, delete a character, replace a character. So input suppose is word1 is equal to horse and word2 is equal to ROS. So we have to convert this word1 and word2 equal to each other, right? So how are we going to do that with using the minimum number of operations? And the operations allowed are: we can insert a character, delete or replace. So given this horse, firstly we are going to replace H with R, so that would result into RORSE. RORSE, then we can remove another R, this one, then it will result into ROSE, and then finally we can remove one single E, which will result into ROS. So what is the number of operations we have to do to convert this word into this word 2 is number of operations is 3, right? Other example is word 1 is intention and word 2 is execution. So if we have over here, we can convert word 1 to word 2 using 5 operations, right? So there are some constraints given to us, and word 1 and word 2 consist of just lowercase English characters. So it looks like a very complex problem, but ideally it is not. So if we try to break this problem into simpler sub problems, I guess we would be able to solve it, right? So let's consider a simple example and try to understand how we can solve it. So the example over here is the first string is HORSE, horse, and the second string is ROS, right? So we need to convert this string HORSE to ROS. So what is the edit distance between these two strings, right? So if we observe carefully, if we are given two strings, right, so if we start from the end of these two strings, suppose horse and ROS, so suppose if we take the last character of these two strings, these are equal. Let's take another example. Suppose HORSE, horse, and ROSE. This is the example. So the last character of these two strings are equal. So whatever the edit distance is for this string HORS and ROS, the same edit distance will be also be there for HORSE and ROSE, because we don't need to do any computation for this particular E, as these are equal. But if these are not equal, then what we need to do is we have three possibilities with us. So this is string 1 S1 and string 2 S2, right? So what are the three possibilities with us? So the edit distance between these two strings can be computed as what is the edit distance between three sub problems. So what are those three sub problems? Let us see. So we will take HORSE and ROS. Let's remove the last character. So HORS and RO. So what is the edit distance between these two substrings, strings basically, right? And what is the edit distance between HORSE? Let's consider this whole string and remove the last character from the second string. What is the edit distance between these two strings, or what is the edit distance between HORS and ROS, between these two strings, right? So what I have done is I have removed the last character from both of the strings, this and this, in the first case. In the second case, I have just removed the last character from the second string, and in the third case I have removed the last character from the first string, right? So this was the input example, ROS. So there are three possibilities that can be there, right? So whatever is the edit distance between these two strings, between these two and these two, I can just increment 1 to those and take the minimum of that, right? So suppose this has a edit distance of X, this has a Y, this has Z. So whatever is the minimum of X, Y, Z, I will just increment 1 to it, and that will be the edit distance between these two strings. How are we going to calculate the edit distance between these two strings? So it will have further three possibilities with them. So I can remove the last characters from these two strings, HOR and R. Similarly, if I just remove the last character from the second string, that is this, and what if I just remove the last character from the first string, like this, right? Similarly, this will have further three possibilities with them, this will have further three possibilities with them, but in this particular case the last character are already equal. So I can be pretty much sure that whatever is the edit distance between HOR and RO, that will be the edit distance between HORS and ROS. So I can just compute the edit distance between HOR and RO. That's it. That will be the same edit distance between HORS and ROS, because we have just similar character at the end of the string, right? So as we can see, like if we draw it in a recursive way, we will be computing the same subproblems again and again. So in this scenario, HOR and RO is present over here as well and over here as well, right? So if we write a recursive solution for this, right, so we will be computing the solutions for these two subproblems again, right? So that would lead to extra time complexity. So can we somehow reduce this time complexity part using some extra space, right? So that's where the dynamic programming comes into picture. So as we have overlapping subproblems and overlapping subproblems problem is there, so we can introduce the concept of DP over here. So how we can do that? So that is also an interesting way. So let's try to see like what are the base cases for the DP in this case first. So suppose we have so it's already given in the question that the word1 and word2 length can be of 0 length, right? So suppose our first string, this is the first string and this is the second string. So suppose the first string is empty and the second string is just h, right? So in this case, what is the edit distance? The edit distance is just 1, because I need to insert one h over here, right? So suppose the first string is again empty and the second string is ho. In that case, the edit distance is 2. If the second string is HOR, the edit distance is 3. If it is S, then edit distance is 4. If the second string is horse, then the edit distance would be 5. Similarly, if the first string is not empty and the second string is empty, it is empty, and the first string is just suppose R, right? So in that case, the edit distance is 1, because I need to remove this, right? Because I have to convert the first string to second string, right? So I will be deleting this first character. If the first string is RO, then in that case the edit distance is 2. If the first string is ROS, the edit distance is 3, right? So why I am doing over calculating these values is, I will tell you just now. So if I draw a 2D array, so in this I am going, in the x-axis I am going to keep one string H, O, R, S and E, yeah, like this, and in this axis I am going to keep my second string ROS, right? So I am going to populate the 0, 1, 2, 3, and over here 0, 1, 2, 3, 4 and 5. Why are these values present? Because suppose this is the ith index and this is the jth index. I and j denotes what is the substring I am considering at a particular moment. So if the first string is empty, this is the first string, if it is empty and the second string is just R, the edit distance would be 1. If the second string is RO, then it is 2, and if the second string is still ROS, then in that case edit distance is 3. Similarly, if the first string is H and the second string is just empty, in that case it will 1, 2, 3, 4 and 5 depending on the length of the first string, right? So I will be now populating these columns row by row, right? So what I am going to do is I will just consider a string present till ith index and present till jth index, right? So what is the edit distance between, if the I value is over here and j value is over here, right? So it means the string is just H and R. So at a particular moment I just need to compute the minimum of 3 particular values. What is the minimum of these 3 values? These 3, I minus 1 j, I j minus 1 and I minus 1 j minus 1. So what is the minimum value of these 3? It is 0. 0 plus 1 would be 1. Similarly, what would be the minimum value between these 3? It would be 1, and 1 plus 1 is 2. what is the minimum value between these three? It will be 2. 2 plus 1 is 3. So that in this way I'm going to populate this whole matrix. So let me just populate it right away. If I value is over here I and j is over here r, right? So let's take the minimum of these three, which is 1. 1 plus 1 is 2, and 1, and this o and this o are same. So I told you that if the last character of a particular string, so ho and ro, so these are same, so I can just completely remove those, right? Ignore those, and whatever the value is present diagonally, like this one, I can just introduce over here, right? And now populating this would be o and s are not equal, so I'm going to take the minimum of those. 1, 1, 2 and 3, the minimum of these three is 1, so I'm going to take that plus 1, just 2. Similarly r and r are equal over here, so I can just take the diagonal value, which is 2. Similarly r and o are not equal, so over here 2, and r and s are also not equal, so it will be 1 plus 1 2. S and R are not equal, so it will be minimum of these 3, which is 2. 2 plus 1 is 3. Minimum of these 3 would be 2. 2 plus 1 3. Similarly these S and S are equal, so I can take diagonal value 2. Now coming here, 3 plus 1 is 4. Over here E and O are not equal, it is 4. Similarly E and S are not equal, so I will take the minimum of these 3, which is 2. 2 plus 1 is 3. So I am going to return this 3 as the answer, right? So let's try to code this solution. It's a very simple solution. I will code it using C++. Right, so I'm going to create two variables. Int n is equal to word1 dot length, sorry, right, and m is equal to word2 right, and let me introduce two more variables, I and j, right? And in the problem it is also given that the length of the basically the words can also be 0. So suppose if n length of any of the strings is 0, so I can just take the length of the other string, right? So for that check if either n or m is 0, so I can just write if n star m is 0, which means any of the values is equal to is 0, then in that case I can return n plus m, right? Suppose if n is 0, then the product would be 0, and in that case n plus m, which will be 0 plus m, right? So that should be fine. Now I need to create the 2D dynamic array, which it is dynamic, so I need to create this array using C++. So that's how I'm going to create a dynamic array of size n cross m. And star dp is equal to new int star, what is the number of rows? Number of rows would be n. Let's make it n plus 1, because one row would be taking care of these zeros, right? And equal to 0, I is less than equal to n plus plus, and dp of I would be equal to new int m plus 1, right? So it is going to create a new array of size dp of n plus 1 and m plus 1, so n plus 1 number of rows and m plus 1 number of columns. Now I have to populate these 0, 1, 2, 3 over here, and similarly the first row and first column have to be populated, right? So let's do that first. For I equal to 0 till I is less than equal to n is plus plus, and this is for the first column, right? So dp of first column, the row value would be I and the column value would be 0, it will be just I. Similarly the first column would be till m, and dp of, so the row value would be 0 and the column value would be I, it would be I, right? So the first row and first column have been populated. Now I'm going to fill the rest of the values. So for that I have to write two for loops, two nested for loops. I is less than equal to n and I plus plus. J is equal to 1, j is less than equal to m, j plus plus. Now I have to do one basic check, that is that if the characters present at the particular ith and jth index are equal or not. Because if those are equal, so suppose this let me just revisit that example. So suppose I am populating this column, right? So here I check I is over here and j is over here, so o and o are equal. In that case, I don't have to take the minimum of these three values. I can directly take whatever the value is present in the diagonal and just populate that over here, right? So that's the check I am going to do. If word1 of I minus 1 is equal to word2 of j minus 1, if that is the case, then my current dp of I comma j ij would be equal to dp of I minus 1 j minus 1, right? And if this is not the case, then my dp of ij would be the minimum value of these three, this one, and this one, right? So that would be the minimum of dp of I minus 1 comma j and dp of I and j minus 1. And let me write it one more thing, dp of I minus 1 j minus 1, that is a diagonal one, right? So I have to write one more minimum over here. That should be fine, right? I have to write a minimum function, but I will write it, no issues. And finally I have to return what is the last value present, this one, right? So that would be dp of n cross m, so nm, right? And I will write one helper function which is going to return in the minimum value. Here I have to pass int a and int b and return. If a is less than b, then I have to return a, otherwise b. That's it, right? I will run this code if there are no compilation issues. Wrong answer. Let me see. Minimum of HORSC. What have I done the initialization correct? In the start dpt equal to new int n plus 1, so it will create a n plus 1 number of pointers, and for each pointer I have to create one more column. dp of I equal to new int n plus 1. Am I doing the initialization correctly? I is less than equal to n, so I am populating the first row, right? First row, yeah. dp of I equal to I. Similarly, I is equal to dp of 0, I is equal to this one should be fine. Word1 is equal to word2 of j minus 1, then in that case dp of ij equal to dp of I j minus 1, otherwise dp ij equal to minimum of dp I minus 1. Oh, I have to increment 1 as well, yeah. But if the words are already equal, if the characters at the last index are equal, I don't have to increment 1, right? I will run this. Yeah, this is fine. Should be fine, I guess. Yeah, runtime memory usage perfectly fine. So I guess, yeah, the solution is clear. So I would recommend you to go through this recursive solution first, because it will help you understand why are we going to the DP approach and why are we not going ahead with the recursive approach. So basically, whenever we are going with the DP approach, so we have one common scenario that we will be recomputing the same cases again and again. So as we have encountered in the recursive tree, like we were computing this sub problem again and again. So that's why we switched to the DP part, right? So what is the time complexity for the DP part? Time complexity would be like we are for a particular character in one string, we are taking over all the characters. So it is of nm. N and m are the respective lengths of the strings. Space complexity wise, it is very obvious that we are computing nm dp array, right? So this should be fine. If you have a better approach or any confusion is there in the existing solution, so I would be happy to answer that. And yeah, I will see you next time with another interesting problem. So until next time, keep practicing, and thank you.